You learned how to accept standard input by using the built-in input function. You also know how to send data to standard output, which is typically the screen, using the print function. Using standard input and output work well for certain types of applications. But if you want to keep data generated by your program, you will need a place to store that data. Also, if you want to retrieve saved data, you'll need techniques to do that as well. One common place to store data is a file. You can read input and write output to a file, just like you can read input from a keyboard and display output on a screen. To open a file, use the built-in open function. To use the open function, simply pass in a path to a file to it. The path can be an absolute or a relative path, and it includes the file name. An absolute path contains the entire path starting at the root of the file system, be that a / in Mac or Linux, or a drive letter in Windows. An example of an absolute path is /var/log/messages. A relative path will contain just the file name or a portion of the path which starts at the current working directory. An example relative path is log/messages. This example assumes the current working directory is already in /var. Using / as a directory separator will be familiar to those who have ever worked on a Unix or Unix-like operating system. However, Python recognizes / even when running on the Windows operating system. The Windows operating system uses backslashes as the directory separator. For example, a valid path in Windows would be c:/log/messages/data.txt. However, in Python, you can use /. An example would be c:/users/JSON/documents, finally /python-notes.txt. Finally, on your screen, we show an example of using a relative path using /. Here we pass in documents /python-notes.txt to the open method. The open function returns a file object, sometimes referred to as a stream object, which can be used to perform operations on the file passed to the open function. To read the entire file at once, use the read method on the file object. The read method returns a string containing the file's contents. In this example, we use the open built-in function to open the etc hosts file. We assign the file object to the host variable. Next, we store the contents of the host file into the host_file_contents variable by using the read method on hosts. Finally, we print the contents to the screen. In this example, the etc host file only contains one line, which is displayed at the bottom of your screen. To modify this example to work on a Windows system, we'll set the host variable to c/windows/system32/drivers/etc/hosts. And remember that Python allows us to use / in Windows paths as well. At the bottom of your screen, you can see the contents of the host file on a Windows system. When reading from a file, Python keeps track of your current position in the file. Since the read method returns the entire file, the current position will be at the end of the file. If you call read again, an empty string will be returned since there is no more data to return at your current position in the file. To change the current file position, use the seek method and pass in a byte offset. For example, to go back to the beginning of the file, pass in 0 to the seek method. To start at the 5th byte of the file, pass in 5 to the seek method. Note that in most cases, the nth byte will correspond to the nth character in the file. However, in some cases it will not. For UTF-8 encoded files, you can encounter characters that are longer than 1 byte. You'll run into this situation when using kanji, Korean, or Chinese, for example. To determine your current position in the file, use the tell method. The first line in this example opens the etc hosts file. Next, the current position is printed to the screen using the tell method. Since the file has just been opened, the position is 0. Next, the entire contents of the host file is read using the read method. The contents of the file are printed to the screen with the print method. Next, we check the current position in the file by executing the tell method again. This time, the position will be at the end of the file. As you'll see in the output on the next screen, calling read again on the file will not produce any output because there's nothing else to read from the file since we are at the end of the file already. We return to the beginning of the file by passing 0 to the seek method on the host file object. We display that position to the screen, and finally we reprint the contents of the file to the screen. Here is the output that I was describing. When you first open a file, the position will be 0. After you call the read method, the position will be at the end of the file. In this case, that position is 20. Notice that there is no output on the next line. That's because we called read on the file when it was already at the end of the file. Finally, we reset the position to be at 0 with a seek method and reprint the contents to the screen using the read method. The read method can accept the number of characters to read. This example displays the first 3 characters of the host file. In this case, the first 3 characters are also the first 3 bytes. When we call the tell method on the file object, it reports that we are at position 3 in the file. It's a good practice to close a file once you're done with it. If your Python application opens many files during its execution, this could lead to a too many open files error. To close a file, use the close method on the file object. In this example, we open a file, read its contents, print it to the screen, and then close it. Each file object has a closed attribute that returns true if the file is closed and false if it is not. You can use this attribute to ensure a file is closed. This example uses an if statement to check if the Boolean returned by the closed attribute is not true. If the file is not closed, then the following code block is executed. In this case, it simply closes the file. To automatically close a file, use the with statement. The format is with followed by a call to the built-in open function where you pass in the path to the file you wish to open. Next, use the word as and follow it with a variable name you would like to use for the file object. Finally, you end the line with a colon. After the file is opened, the code block that follows it is executed. When that code block finishes, Python will automatically close the file. Also, if the code block is interrupted for any reason, including an exception, the file is closed. This example demonstrates automatically closing a file. First, we announce we're opening the file. Next, we use the with statement to open the host file and assign the file object to the host variable. From there, we start executing the code in the code block. First, we check to see if the file is closed, and it's not closed since the with statement opened the file. Next, we display the contents to the screen, which ends the code block. We print a nice message explaining that the file is closed, and finally we confirm that it is indeed closed by checking the closed attribute on the host file object, which correctly reports that the file is closed. To read a file one line at a time, use a for loop. The format is for line variable in file object variable followed by a code block. At the top of your screen is the contents of the file.txt file. In the middle of your screen is the code that first opens the file. Next, we loop through the file one line at a time and print each line to the screen. The output of that code is displayed at the bottom of your screen. In the output, there is a blank line between each one of the lines in the file. This is because the line variable contains the complete line from the file, which includes a carriage return or new line character. Let's update the example and remove the trailing white space, including the new line and carriage return characters, by using the rstrip_string method. Now you can see that the output is what we would have expected. When opening a file, you can specify a mode. To do so, first pass in the file to open to the open built-in function, then follow it with a comma, and then supply the mode. So far, we've been using the default mode of R, which opens a file in read-only mode. If you want to write to a file, clearing any of its existing contents, use the W mode. If you want to create a new file and write to it, use the X mode. If the file already exists, an exception will be raised. Using the X mode prevents you from accidentally overwriting existing files. If you want to keep the contents of an existing file and append or add additional data to it, use the A mode. With both the W and A modes, if the file does not already exist, it will be created. If you want to read and write to the same file, use the plus mode. You can also specify if the file you're working with is a text file or a binary file. By default, all files are opened as text files unless otherwise specified. Simply append a T or B to one of the read or write modes. For instance, to open a file for reading in binary mode, use RB. To append to a binary file, use AB. Text files contain strings while binary files contain a series of bytes. Said another way, text files are human-readable and binary files are not. Examples of binary files include images, videos, and compressed files. To check the current mode of a file, use the mode attribute on a file object. In this example, you can see that the default mode of R is used when opening a file. Now that you know about the different file modes, let's write some data to a file. It's as easy as calling the write method on the file object and supplying the text you wish to write to the file. First, we open a file for writing by using the with statement so that it automatically closes when we're finished with it. Notice how we supplied a W as the second argument to the open function. Next, we use the write method and provide some text. We call the write method again and supply even more text. Finally, we open the file again in read-only mode and print its contents. The output, which is displayed at the bottom of your screen, might not be what you expected. The write method writes exactly what was provided to it. In this example, no carriage return or line feed was provided, so all the text ended up on the same line. The /r sequence represents a carriage return, and the /n represents a new line. Unix-style line endings only contain the /n character. Mac and Linux files use this type of line ending. Windows-style line endings can be created using /r/n. Let's try our example again, but this time using a line feed character at the end of the line. You can see that /n was provided at the end of the string we pass into the write method. At the bottom of your screen, the output is as you would expect. The main thing to remember about binary files is that you are dealing with bytes, not characters. The read method accepts bytes as an argument when dealing with binary files. Remember that the read method accepts characters when the file is opened as a text file. This example opens up a picture of a cat in binary mode. We seek to position 2 using the seek method on the file object. Next, we read 4 bytes from the file using the read method. Next, we print to the screen the current file position, which is 6. Finally, we display the mode of the file, which is RB. Working with anything that exists outside of your program increases the chances for errors and exceptions. Working with files falls well within this category. For example, a file you are attempting to write to may be read-only. A file you are attempting to read from may not be available. In a previous lesson, you learned about try-except blocks. Let's put it to use here in this example. Here we attempt to store the contents of the contact.txt file in the contacts variable. If an exception is thrown in this try block, the except block will be executed. To continue gracefully in our program, we simply create the contacts variable with an empty string. In the example output on your screen, the contacts.txt file existed and was able to be read, and resulted in a string with a length of 319. If the file couldn't be opened, the output would read 0, which is the length of the empty string assigned to the contact variable in the except block.